Greetings! Today we're going to talk about finding a sample size with a specific margin of error, a specific confidence, and we're actually going to do this in two parts. So this is a really good video to download. So if you selected this for download, great. If you didn't, well, then you probably want to go to the link and download this, but that's another story for another day. Let's proceed, shall we? So one of the first items that we want to start dealing with is figuring out what does it mean to do a sample size equation. Now the formula is being presented to you accordingly. Nothing wrong with this formula. Okay, we're going to show you how to break it down piece by piece, and we're going to explain everything as we go along. Now this first part involves the prior estimates, while the second part involves the most math. Now every single one of these components will be given to you in one way, shape, or form. For instance, the E is known as the amount of error, the Z sub alpha over 2 is the critical value, and the P hat is obviously a prior estimate. So all these parts were given to you accordingly, but we're going to start talking about that more in depth in just a few seconds. Get a moment, write this formula down because you're going to want it. All right, let's get together and start finding the pieces. Now, when we're talking about pieces, we want to make sure that we get everything that we need. And one of the first things that we need to talk about is confidence, estimates, and the error. Now, all these were given on the first page. If you want to check it, go all the way back to that page at the very beginning of the video, and that will help you see where all this came from. Okay, now when we're talking about prior estimates in sample sizes, we refer to them as a P hat. Okay, and that's 0.52. Now we need to evaluate its counterpart, which is the 1 minus P hat, which is just simply 1 minus 0.52. Now, for those of you who can do this really quickly, you should get to about 0.48. If not, pull out your calculators, get started, but it is 0.48. All right, take a moment. You need your P hat and you need your 1 minus P hat because we are given a prior estimate. Okay, now the next part that we need to deal with is that within section. That within is the same as your E because it is a certain error. Now, if they give you a percentage for error, make sure that you write it in decimal form. Otherwise, you're going to mess up your entire problem. All right, here we go. And more importantly, this 99% confidence, what the heck are we going to do with that? Well, that 99% confidence gives us our critical value. Now, for those of you who know about finding critical values and when you're given a level of confidence, you should be able to think immediately that we need to take that level of confidence, subtract it from 1, and cut it in half for that alpha over 2. Okay? Now, the reason why we are doing this is because we want to figure out that alpha over 2. If you're confused about finding the critical value, I have another video set which is called Critical Values Tutorial. That will show you how to do it by hand. Now, if, and I emphasize if, you want to use a calculator for it, such as a TI 83 or 84, I don't have that up and running yet, but I should pretty soon after the third week of July 2000, what year is this? 15. But again, beside the point. Let's get this rolling. So if you do your math appropriately, you should get about 0.01 cut in half, and that gets you about 0.005. So again, all this is done in a calculator, or this should be really quick math. In other words, if I give you 99% confidence, you should be able to tell me a alpha over 2 of 0.005. Okay? And why is this important? The critical values video tells you, but more importantly, that Z sub 0.005 is fixed at one specific value. And that value is at, I believe it's 2.58. Oh, so it is 2.58. So when you see a 99% confidence, you should think a critical value of 2.58. Or just look in the critical value video and you can evaluate it from there, but I'm regressing. So we're going to write out our formula one last time, and we should have all the components now. The p hat, the 1 minus p hat, the z sub alpha over 2, the margin of error, and this whole thing is being squared. So we got our 0.52 times our 0.48, and again, we're just filling in the blanks here, folks. There's nothing wrong with this. We're just filling in the blanks. So z sub alpha over 2, 2.58, the margin of error, 0.03, the whole thing being squared. So we just rewrote the problem. And if you do this math, okay, now I'm going to stop this for a second. If you do the 0.52 times the 0.48, you should get 0.2496. I'm going to verify this on my calculator for a second. 0.52 times 0.48 should give us 0.2496. This value is exceptionally important because it is generated by your prior estimate. So make sure you don't lose that. Now take a moment while we're still here and figure out this internal value. So you should be able to do 2.58 divided by 0.03. Okay, that comes out to anybody? 86. And we're going to square that. So if we do one more line of math, you should get 0.2496 times 86 squared, which is 7,396. Now that we've done all this math, so we've started from the very top, work our way down step by step, nothing wrong with this. Some people can do this a lot quicker and do it in one particular calculator step. Some people want to see it in multiple steps. That's fine. Just don't forget about this square. And another thing, this value has to be a large number. It can't be a small decimal value. And the reason why is because if you multiply a decimal by a decimal, you're not going to get anywhere. So this needs to be a very large number. Well, I'm not going to say large. Make sure it's over 1, at least over 1. And then we'll work with it from there. So you should have multiplied these two values together by now and gotten about 1,847. Now, one last piece of the puzzle. If this was 1,846.0001, you still round up to the next whole integer. Regardless of what that decimal value is, you always round up. Okay? Now it didn't happen in this question, but it may happen in some of your other questions in the near future. Okay? So keep an eye out for that decimal value. You cannot have a decimal value in sample size. That's like saying, can I have, 0.25 of a girlfriend? I wouldn't want to do that. Well, no, I wouldn't want to do that. But that's also like a wife telling her husband, you know what, I love you when you're here, but I only want 1/10 of your body. You can't have 1/10 of a husband. You either take him as he is or you just put him off to the side. But don't chop him up into small pieces. If you're chopping up husbands, we need to talk. So now we're going to go up into no prior estimates. So the first thing I want you to acknowledge is that the critical value will remain the same. The math that we did earlier in the video will remain the same. Next, the error is also going to be the same. That hasn't changed in this problem. But the one thing that did change is the fact that we have no prior estimates. So what happens to that p hat times the 1 minus p hat? Well, we come up with a worst case scenario for the p hat times 1 minus p hat. It's mathematically proven. I'm not going to do it in this video, but you do have to know that if no prior estimates are given, that we change the p hat times 1 minus p hat to 0.25. Aha, 0.25. Interesting. And that's a worst case scenario? Well, let's plug it into our formula. Let's see what happens. So I'm going to rewrite the formula. The p hat times the 1 minus p hat times the z sub alpha over 2, which was z sub 0.005, cut up by the margin of error, squared. Well, that p hat times 1 minus p hat is 0.25 this time. That's all we did. If no prior estimate is given, you take this huge chunk right here and you cut it down to 0.25. Nothing more. Just keep it as that. Don't move it. Don't change it. Just leave it as 0.25. Next up, we're going to start working with this value. So we're going to plug in our numbers, which was the 2.58 from the previous slide, and the 0.03, which we already knew, squared. And if we do a little bit more of the math, okay, so we get 0.25 times 86 squared. Okay, now that was from the inside of this parentheses, and we did this earlier on in the video, so a lot of this seems repetitive. The only thing that we've done is we've changed this huge section right over here. But does changing that affect the answer? Let's take a look. So 0.25 times 86 squared comes out to, let's see here, that comes out to 1,849. So it does change the answer a little bit. Actually, it does change the answer quite a bit. But the numbers that we obtained are the sample sizes required for the prior estimate and the non-prior estimate. This was the no prior estimates, and the answer from the previous slides were the prior estimate of 0.52. Signing off. Enjoy.